Okay, so now we talked about how we converted exponential into logarithms. So now let's talk about why, or where the logarithms actually come from, so we know why we have to convert them. So we're going to first remind you, okay, we're going to remember our graph of an exponential in base 2. Okay, we had these from your couple notes ago that you can refer back to. When you plug in these into your exponent to base 2, we get these values, and when they graph, it gives us our exponential graph that's increasing. Okay, it has a domain, all real numbers, all the way across. It has a range of from 0 above, but notice it doesn't ever hit 0 because it gets closer and closer. The y value is closer and closer, but never gets to 0. So we have that horizontal asymptote at 0. Now, is this a function? Yes, it passes vertical line test, right? So what we're going to do next is we're going to talk about how would I find the inverse of an exponential equation. Okay, so if we remember, the first thing we have to do, if I know a graph, here's my graph, how do I find the inverse? Well, if we remember, we are going to find the flip the x and the y to that graph. Okay, so magically, I've flipped our x's and y's, and I've graphed those 5 points. And if you notice, if I was to actually go farther, if we had up here 3, 8, we'd also have 8, 3. So 8, 3 would be here. And notice, so what's happening is it's going to the right, it's going up, but it is getting larger and larger. But as we go toward the y-axis, it's going to get closer and closer. You get the 1/2, the 1/4, and it's going to get closer and closer. But it's never going to get to the y-axis, which means we don't have a horizontal asymptote anymore. The inverse, we would get our vertical asymptote. Okay, so now we're going to have a vertical asymptote at x is equal to 0. Okay, so that's a good thing. So far, so good. Okay, now what would its new domain be? Well, domain, well, it's going to stop at 0, 0 to infinity, which is what the range used to be. And remember, one of the rules for inverses is your domain and range is going to flip. So that should mean my range goes forever down, forever up is all real numbers, just like the domain was in the exponential. Now, is the inverse a function? Well, if you look at it, yes it is. Okay? And since it's a function, that means we could give it, this function is now the inverse function. Okay? So, if I can find the inverse graphically, I should be able to find it through algebra. Okay? So, let's look at it, finding the inverse through algebra. Well, here's my original exponential. We're always supposed to switch the x and y. So if I switch the x and y, we'll have 2y is equal to x. And then we have to calculate the inverse, you have to solve for y. Well, notice the y is now in the exponent. Whoop, I can't spell. Exponent. Alright, there's the word right there. Alright, so how do I solve for something in the exponent? If y is in the exponent, how do we solve that? And that's why mathematicians came up with the logarithm. Okay? And so if we go back to what we learned in the last video, if I wanted to convert this to a logarithm, base 2, it would be the log base 2 of y, of x, sorry, or here in this case, whoops, we're going to solve this one, my bad. Okay, we got to solve this one. How do I solve that for y? We change it to a logarithm, and we're going to get log base 2, I knew something was wrong, of x is equal to y. And so now this is solved. Okay, so the inverse of 2x is equal to y is going to be the log base 2 of y is equal to x. And that's that flipping going back and forth. Okay? So, let's look at these. How do I solve these? Okay? Well, the way we're going to solve this is I'm going to take 6 of some exponent is equal to 36. Okay? So, well, what number is going to be the exponent of 6 to give me 36? Well, the answer is going to be 2. And that's how we evaluate. Okay? A lot of times, the evaluation is just going to look like that. Okay? Log base 5 of 125. What's my answer? Well, it's going to be 5 of some exponent is equal to 125, which happens to be 3. Same thing here. 2 to what exponent is equal to 1/8? Well, how am I going to deal with that? Well, we know that 2 cubed is 8, right? So how do I get the 8 to be at the bottom? We make it -3. Okay? 3 to what exponent is equal to 81? 4. Now these last two talks about also what we learned on that last. When we were converting, we also talked about special logs. Okay? So if it says log of 1,000, what base are we talking about? We're talking about base 10. So 10 to what exponent is 1,000? That would be 3. And this last one, which is kind of an interesting problem, remember what this means? This is the natural log. And the natural log is base e. So how would I write this? How would I solve this? Well, it's going to be e to what exponent is equal to e squared? Well, how would I make those equal? What would the question mark have to be? Well, it has to be 2. Okay? Oh, that's a horrible 2. Alright, so that's how we convert or evaluate a logarithm. Okay? So that's what we want you to be able to deal with when we do these problems. Okay? Hope this helps.